Hello and welcome. Today's episode of Food Chain is coming to you all the way from Belhaven as the eastern part of North Carolina in the United States of America. Today we are looking at the agricultural value chain in the United States. We are also speaking to growers, scientists, producers, anyone along the agricultural value chain, purposely or focusing on genetically engineered crops. My name is Emma Davis and you like to stick a stay.
The term biotechnology was coined by a Hungarian engineer, Karl Ehricke, in 1919 to refer to the science and methods that permit products to be produced from raw materials with the aid of living organisms. Since then, biotechnology has transformed various industries, including producing many biopharmaceuticals and vaccines, helping forensic experts with DNA fingerprinting and profiling, and converting biomass into biofuels, among others. In agriculture, biotechnology aims to introduce sustainable agricultural practices with best yield potential and minimal adverse effects on the environment. A key area of application is pest management, as emphasized by Dr. Dominic Rusigi, an entomologist at North Carolina State University's Extension.
So we'd have a scout would go into the field. They'd use they'd use one of these. They'd sample different portions of the field. You wouldn't just want to sample the edge or the middle or whatever else. And then they would take an average and they would say, from that average, if I have this many corn earworm per row feet, should I apply an insecticide? So that's a pretty basic concept that we use. And we do a lot of work reevaluating economic thresholds because they change over time as farming practices change. So, and then new pests come in that we have to develop economic thresholds for. So we just do a lot of work with that. It yields more when you grow it as an annual, but it makes producing a tropical plant in a non-tropical location difficult. It thinks it's a tree because it is, and what it produces are pre-floral buds that we call squares. And when the plant is stressed, it tends to drop those squares. So it could be from environmental stress or it could be from an insect. And that's not good for cotton production because you need to retain the squares to have bolls to pollinate so you can make the lint inside of the bolls, right? So in North Carolina, we really have to struggle early season because we're on the northern limits of cotton production. When we plant cotton in May, it tends to be a little bit cold for the plant. It comes up and it just kind of sits there, and we really want the plant to grow very quickly. And the plant's a tropical tree. It's not worried about growing quickly. It's developing a root system, right? Because it's gonna be a tree, but we really don't want it to be a tree. And then we have to make sure we retain these squares later on in the season. And so cotton insect management has been very, very dynamic in North Carolina. It changes all the time. Prior to the 1980s, we had a very important insect pest called the boll weevil, which I'm sure you've heard of. The boll weevil really limited cotton production. There was a massive area-wide eradication program to eliminate boll weevil from the United States. It's now been eliminated except for parts of southern Texas and Mexico, and they're working really hard on eradicating it there. After boll weevil was eliminated as a problem, the primary insect pests we managed were an insect called the bollworm, which is the same insect you saw earlier, just with a different name, the corn earworm, and an insect called the tobacco budworm. Tobacco budworm and bollworm are very closely related. They look very similar. They have some different habits and preferences and host preferences and things like that. In 1996, when BT cotton was commercialized, tobacco budworm was eliminated as a pest in the system. BT cotton for tobacco budworm, I would say arguably has been the most successful out of any pest that we've tried to control. We mentioned European corn borer earlier. We have resistance to European corn borer now in the upper Midwest and parts of Canada. We have never, to my knowledge, been able to grow a tobacco budworm on BT cotton. It just completely eliminates the issue. Bollworm is a different issue, right? Corn earworm. the traits were not quite as effective for bollworm, and so that continues to persist as a problem. Because we sprayed cotton less, other insects moved in to fill the niche, and those were insects in the piercing sucking complex. You may have heard of stink bugs. They've got a hypodermic needle called a stylet. They feed inside of bowls on the seed. The seed develops the lint, and so the stink bugs can rob yield directly by feeding on the seed, reducing lint production, but they can also introduce pathogens into the bowls that can rot the lint. Once we got our management on stink bugs, another insect started to become a problem, the tarnished plant bug. So we're going to look at some tarnished plant bug here. And then another insect that we've had to contend with early season is called thrips. Thrips is a very small insect, maybe the size of a pepper. They're all over this plant. They're just kind of too tiny to see. When the plant emerges as a seedling, it's got these big fleshy pads called cotyledons. Maybe you've seen that when you've seen seedlings emerge. Those thrips preferentially lay eggs in the cotyledons. The larva thrips emerge from those cotyledons and begin to feed on the developing leaf, and they hold that plant back. And so we really want to release the plant so we can grow. We want to get rid of the thrips. And the tarnished plant bugs later on in the season feed on these squares with their piercing, sucking mouth parts. The squares subside. We want to retain those squares. And so the traditional way that we've managed both of these insects has been with foliar insecticides. Bayer has developed a new type of BT that is the first commercially available BT that targets piercing sucking insect pests.
So BT crops don't only just use fry, they have other proteins from BT?
Yeah, so some of them are coming from, we're going to ask, but the ones, the dip, that's also from Bacillus thuringiensis.
Okay,
But
here's an immature, that's a nymph tarnished plant bug there. There's another nymph tarnished plant bug. There's one right there. There's one right there. And our economic threshold we talked about is 2 to 3 per sample. And I'm counting 1, 2, 3, 4, 5. So there's one that's just about to molt into an adult. So you can see that this is a field that I really should spray, but I'm not going to because it's a research plot.
Are the red ones mites or aphids?
This is an immature minute pirate bug. It's a predatory insect. And we mentioned how corn earworm is such a big pest of soybeans. We have a really hard time showing economic loss in field corn for corn earworm, even though like every year it gets infested. Cotton, on the other hand, we can have 100% yield loss from this insect because one larvae can consume 17 different tissues. And remember what I told you about cotton, how it'll just subside the tissue off the plant. So you can look down the rows here and you can see all these plant parts that have fallen off of the plant. And even just a little pin prick through the carpal wall of this bowl or square will cause the tissue to abscise.
A third-generation farmer and seed producer at Belhaven in North Carolina, Darren Armstrong, grows corn, cotton, soybean, wheat, and oats. He explains how biotechnology has revolutionized his farming practices and improved productivity.
Growing the conventional crops like we did years ago, of course I still have some now, but when we were 100% conventional crops, it was a lot more trips over the field. It was a lot more volume of chemicals that we were using. We also had to use a whole lot more tillage, so you had more wind erosion, more water erosion. So switching to the GMO technology, we've been able to do more no-till, cut down on any erosion problems, be able to save our organic matter in our soil, where you keep a cover on it, where the sun's not baking down on it, water's not washing it away, wind's blowing it away. So we've been able to utilize more of the no-till management practice, and I think make less trips with less volume of chemicals over the field.
Okay, how long or when did you decide to, introduce GM or grow GM crops? And then
what are some of the pushbacks you faced as a farmer?
Right. So we started using the technology as soon as it was available. I would say in the mid 90s. So it's been out about 27 or 28 years now, and we were using it just about immediately as soon as it was available to farmers. We've always been seed producers, so the technology that's the newest, it seems like. If you're growing seed, you're always probably a year or so ahead of everybody else getting the seed produced. So we started using it back then, and could see immediately, the difference that it made in whether it was the process of what we were doing, which tillage technique we were using, the hours that we spent on the farm, the amount of equipment we used, the amount of diesel fuel we used. You could just see that technology was making those things better. So as time went on, we continued to use that technology, and then as things came out that enhanced it or made it better, we adapted those pretty quick, just because we could just really feel the benefits of it. And the pushback we get from people, a lot of our food or our grain goes to animal feed. So most of it is not directly going into the human food chain like a sweet corn or something would be. So as far as at home, personally, I really have not had any kickback as far as that goes on it, other than some articles and some things that you read. My international travels is completely different, and I've seen a lot of kickback on it there, distrust questions and things that really people are emotional about with their food, and want to have that discussion, and of course we're always willing to have that. So
how have you dealt with that?
I think just being understanding and conscious of somebody's concern to the food chain, because that's something that affects every person on the planet. So people have to be confident in their food chain. And of course, I have to be confident in producing. Certainly, there's no advantage to me to produce anything that would negatively affect in any way the consumer, because they're the ones who's buying our products at the end of the day. So being very mindful of their concerns and why they are approaching this the way they are, but also being willing to say, this is our history. We've been this many 20 plus years without any health issues related to this technology. It is safe. This is why we use it. We feel like it is safer and more sustainable than any other practice that we've ever used. And that's why we have chosen this direction and this management practice to use. And it's extremely important for the future going forward, is that we continue to develop new technologies based off of this and to get them approved in a timely manner.
With this part of town, the main problems have been drought and salinity. Are they the issues you're also facing, and how are you dealing with them?
So the salinity is from saltwater intrusion coming in from the rivers and the sounds that are brackish, or maybe even an ocean who's salty, because we are out next to the coast. And you have storms that build up out into the Atlantic Ocean and come in, will bring storm surge and that type of thing to areas that you wouldn't maybe ordinarily have them. So those are definitely the challenges, and these are all weather challenges. A drought, we just came through one this past summer, which really damaged the corn crop. But we saw the genetic superiority of these plants being able to handle a weather extreme better than anything that we've seen in the past. So whereas they're not perfect, they're not going to to shut it down and be able to tolerate anything, we've seen significant increase in what a plant is capable of tolerating going forward. And each time there's a discovery made or an improvement made that gets a little better each year. And as a result, if you look at, say, for example, the corn yield of the United States, it is increasingly going up a little bit every year. And what that means is the more supply you have of something, the more affordable it is. So the idea is that you can grow a safe, abundant crop where everybody on this planet is able to afford that and have the ability to feed their family. They may live in a place where you can't grow corn, but maybe they can do something else. Maybe they can produce something else, and we can trade, palm oil, or you can trade equipment, or there's that trade goes on, and it grows the economy where everybody can participate in it. And that's what the main thing is to be able to sustain our people and peoples of other countries, so they can live a peaceful life and to be able to feed their families and have a good quality of life.
Okay, will it be safe to say you enjoy what you do, and how has the international role you play impacted you as a person?
I do love what I do. To get to go to work on a farm every day in agriculture is a tremendous blessing to me and my family. It's very rewarding, even from home, when you get to look across the field and you see that you've produced something and it's a healthy crop, and you've had these challenges to overcome, whether it's weather or some sort of insects or whatever problems that we have, that you've been able to overcome those and still produce a good, healthy, safe crop is very rewarding. And then to be able to go overseas and to other places that maybe their economy is not as developed as ours, and to see what it means to those people that all of a sudden you're growing enough grain that it's available to these people, and you see the quality of life improve in those places. Just really broadens your view of the world and how important it is that U.S. agriculture continues to run like we've been doing, and to keep making the improvements that we've made in the past years.
Talk of international markets, Africa. Do what are your plans, your engagements, and all that?
Yeah, I think our trade groups like the U.S. Grains Council have got people working in Africa currently. That would be an incredible market to be able to be more involved in. Like I said, there's some political challenges, there's some things that make it tough. That one reason why people probably haven't been there a whole lot before now. But as the world evolves, and some of those barriers maybe come down, and if you get one or two countries that are able to participate in that, all of a sudden now you've got a place that you can trade that you hadn't traded before. And we are producing enough grain that we can go into these countries. We need to be in these countries because they're very important customers. So maybe in the past, maybe we didn't have enough grain to do it. In the 1950s and the 1960s, everybody didn't have an abundance of grain. Well, now you're seeing not only our country, but India and Brazil, and all of these places are looking to export grain. And a market like Africa is going to be more and more important.
Soil and water are critical factors for crop yields, whether using conventional or genetically engineered methods. Professor Ekrim Oslu, a soil management specialist at North Carolina State University, shares insights on best practices for soil management.
Soil management practices includes, but not limited with, tillage practices, cover croppings, integrated crop livestock systems, application of organic amendments. They all aim to improve the soil health and improve the productivity in the fields. Tillage managements or other managements, they all could be classified differently, but one of the most efficient way of viewing these perspectives could be conventional practices versus conservation practices or sustainable practices. So when we talk about the tillage as a soil management practices, we could talk about the different intensity and aggressiveness of tillage, which goes from the traditional mower plow to no-till systems, which also include disking, ripping, chiseling, or strip tilling, or other management tillage practices that could be involved in soil management perspective. There are also cover crop integration in crop rotations, which could be using the legumes or cereals in between the two cash crops, corn, soybean, or other crops like cotton. And these cover crops could improve the soil's health over the time and be more supportive to the cash crops. So we do manage soils for corn, soybean, cotton, and peanut and other crops in North Carolina, and we use the rye and crimson clover are the most choiced cover crops in the region. And putting them in crop rotations increase the cropping system diversity. This biodiversity in return provide more microbial community structures and also their activities in the soils, which could eventually improve the functionality of soil. We also have soil amendments application as part of soil management, which could be named as biochar or manure or other compost or green manure. Those could be called organic amendments that we apply in the field to improve productivity.
Does the location determine the type of or the form of soil management?
Definitely. So soil formation is depending on 5 factors, and topography and parent material are 2 factors that are indicating the soil's condition where they present. So definitely the soil type in the field is very important for deciding in what management practices need to be done, and also climate variability. And another factor would be timing. What management practices or what cropping systems that we are doing for how long already. So if we know how soil have been treated in the past by climate, by soil type, by human, by topography, then we would have a better understanding of that soil when we decide what management need to be done, so we can predict what will happen in the decision we made for that soils.
How does biotech play a role in this?
It is a very significant component to think about, because biotech is not only an aspect, but also is a new development, is an innovation in the field. Like organism effect is huge, and even though the soil organic matter indicate about the 5% of the soil, it involved the carbon, nitrogen, organic matter. These are basically energy and production source of that. And engineering of those materials which has high energy, and also the engineering of the microorganisms which run the show in the soils for better productivity is very critical.
Now let's hear from a PhD candidate in biological and agriculture engineering at North Carolina State University, Dana Mugisa, whose research is being conducted at the Tidewater Research Station.
This is the Tidewater Research Station, and I have been looking at the climate resilience of 4 corn hybrids and 4 soybean varieties for the last 3 years. And the goal is for us to impose different water stresses to these different corn hybrids and soybean varieties and see how they respond, look at their yield response, look at the nutrient uptake and the economic implications of the different in structure and the benefits to the farmer. So we have 3 soil water conditions that we impose down here. We have the dry soil water condition, we have the optimal soil water condition, and then we have the wet soil water condition. So we have drainage on site. We have 2 drainage systems. One is the shallow drainage system and the other is a deep drainage system. We operate those to simulate the dry soil water conditions, and for the optimal, in addition to the drainage systems, we then irrigate those different plots, and so we achieve the optimal soil water conditions. For the wet, we turn off the drainage and we use subsurface irrigation and drip irrigation to bring the water table up to 1 foot, 1 foot close to the soil surface. So what our results have shown is really the fact that the interaction of the genetics, and with genetics I'm speaking to the hybrids and the varieties that you plant. Our results have shown that the interaction of the genetics and the environment really matters. For example, if you have dry water conditions or wet soil water conditions, it's very important to have an idea of what hybrid or variety to plant, as we've seen differences in that. However, what we've also seen is that if you invest in irrigation and drainage, then you are able to nullify or to eliminate the effect of genetics. So with where the world is going with climate change, it's going to be imperative that these tools are really evaluated and chosen very carefully, so that to be able to feed the world in the coming years. So this is called a water shuttle, and this also manually collects the water table. It also does the same thing, logging it throughout. I used to come twice a month, so it's logging hourly, and after every 2 weeks I just come, collect the data off, store that, collect all the different data off, and just compare, are there any differences? If this has failed, do I have it somewhere else? So we have all of them placed at the same distance. You have to make sure you keep track of that, because gravity changes the results that you have. So I also measure the manual water depth when I come. That's the most important, because it's a manual one that you've taken. Sensors could fail, but when you have that manual one, then you can use it to back calculate everything else. So this is pretty much of what I used to do, just tracking this bi-weekly.
So comparing it back home,
Yeah.
what would you say?
Well, comparing it back home, I would say that at least where I come from, our government should think about investing in improving agriculture, and that is like investing in different infrastructure like irrigation and drainage. For example, I know in my country we still use bottled irrigation. So yeah, looking into investment in agriculture to help curb down the climate change effects that are going to happen and that are still happening.
As we have seen today, biotechnology is more than just scientific advancements. It's a powerful tool driving agricultural innovation and sustainability in North Carolina. Through the insights of experts and the experiences of farmers like Darren Armstrong, it is clear that biotechnology is transforming the way farmers work and the food we consume. That's it for Food Chain. Thank you for joining us as we explored the intersection of science and farming. Until next time, I am Emma Davis.